Okay, today's May 16, 2011. You're on textbook page 368, and in your blue notebook, page 325. We're on lesson 6.6. Our test is Wednesday. So, you need to have a strong grasp of how to draw sine x on a graph. And a lot of the test is going to focus on transforming that wave. So moving it left, right, up, down, stretching it, and flipping it. Much like we did with the parabolas in our very first chapter. So, I need you guys, these are kind of like condensed notes in a way. If you need to write them, just push pause. Okay, me? There you go. Okay, we're going to go on to an example on the next page of this. Okay, so here's our first example. We've made up this question. F of x is equal to 4 sine x minus 90 plus 2. Okay? This is our theoretical model. If you guys remember, 4 is going to represent A. So that's going to deal with stretching the graph, compressing it, and or flipping it. Our negative 90 is going to be our H, and our positive 2 will be our K. So those are the three numbers we're going to have to move, to move this graph. When you're given a function like this, there will sometimes be a restriction. It'll say to draw the letter x between these two sets of degrees. So that means on your x-axis, you only need to start at negative 450 and go to positive 450. So it'll give you an idea of how long you have to draw this wave for. Maybe it'll be between 360, maybe it'll be between 0 and 360. Okay? If you were to go longer, I really don't care because you've encompassed it. But if you go shorter, that means you haven't drawn enough of this graph for the question. So make sure you can read the restriction. This says draw x between negative 450 and positive 450. Okay? So first thing we're going to do is we're going to draw our normal function, which is f at x equals sine x. If you guys remember, our key points are at 0, 90 and 1, 0 and 180, 270, negative 1, 360 and 0, and then the wave repeats. Then we go backwards in the same idea. Okay? So, oh geez. Because of the scale I've drawn this at, our sine wave looks relatively flat. Something looks off there. I just drew probably. Okay, that's roughly what our wave looks like. Okay, if they ever ask for key points of a sine wave, they're talking about 1, 2, 3, 4, and 5. These are 5 key points on a sine wave. We have 0 and 0, 90 and 1, 180 and 0, 270 and negative 1, 360 and 0. Oh, geez. Can't get that 0 in. And finally, oh, that's it. Those are 5 key points on a sine graph, okay? So, I could technically start with anything I like. I could start with the stretching of A, movement of H, or movement of K. I'm going to stretch and flip it first. I'm going to deal with A. Personally, I think that's easier to do. Whatever you find easiest, you can work with first. But we're going to work with A. I don't know why. Okay. So, like I said, we're going to start with our A. And normally, in our original function, A is the value of 1. If you guys remember, there's nothing there, so we assume it's a 1. And that makes sense because the amplitude of our original wave is just 1. So since our new A is 4, we're going to be drawing the exact same wave. We'll do the new one in red. The exact same wave, except when it's not at 0, we're stretching it by a factor of 4. So all of our 0 points are the exact same. 360, 180, 0, 180, and 360. All the exact same. 90, we're normally at 1 on the y-axis. Because A is 4, we now stretch it by a factor of 4. So that means we go down 4 also when we're supposed to be at -1. So our new graph, to start with our very first transformation, has been stretched by a factor of 4. Okay? So our original A was 1. Our new one, the amplitude is a 4. Okay? You can always tell the amplitude of the graph by just looking at A. It's going to give it right to us. So we've dealt with our 4. Next movement, I'm going to do, let's do K, just because it's usually a little more straightforward. K is +2, which means we're going to move the entire wave 2 units on the y-axis. So we're going to draw our new movement. Our very first movement was from black to red. Let's put that in. Step 1. Step 1 was our very first one. Our step 2 was done in red. Okay? Our step 3 is done in green. Okay, so our step 3 has been done in green, so we're going from red to green now. So my red graph we have here, and our K is +2. So I'm going to take all my major points, okay? If you guys remember, that's our 0, our another one is 94. I'm just going to move them up 4. So 0 and 0 is now going to become 0 and 4. Sorry, not move up 4, we're moving up 2. Come nobody was on me about that. Our K is +2, so we're moving up 2. So 0 and 0 becomes 0 and 2. 90 and 4 becomes 90 and 6. Our 270 and -4 becomes 270 and -2. Everything is shifting up 2. So you get every single point, just move it up 2 units. So our new graph, our step 3, is done in green. The entire wave has moved up 2 units on the y-axis. And finally, step 4 is our last step, so our final graph is going to be written in blue. We'll take a look. It says -90. So when our h is negative, that means we're moving in which direction? Yes, we're moving in a positive direction. So we're going to move right. And we're going to take all these units and we're going to move them 90 degrees to the right. So in other words, I take my top point here. This one's going to be easiest to move. 90 to the right. When I'm at 90, that means I'm moving over to 180. When I'm at 180, I'm moving over to 270. When I'm at 270, I'm moving over to 360. When I'm at 360, I'm moving over to 450. So everything is moving to the right 90 degrees, or 90 units, you could say. It does look much messier than before. Now here's the key. I've moved everything to the right. I still have to continue this wave because it told me to draw between 450, sorry, -450 and +450. So where's my new -450 going to be? Can anyone tell me? Anyone know where on the y-axis? Let's work backwards so it makes sense. If you really get stuck, you can just continue the pattern. So we go down, up, down. Up, that's a little off. That's supposed to go through the dot. Down. And we're supposed to create our new 450. We looked at the pattern. We'd be heading up again. Okay? So our final graph is actually in blue. So this one here is our final graph. If it doesn't ask you for every step, you can just give me the final graph if you like. Okay? That is our final wave graph, or sine. Ready? I'm going to write a quick note what each of those steps were. So step 1 was the original. Okay? Step 2 was, how can I write stretch? S-T. Stretch of 4. Okay? Step 3 was up to. And step 4 was to the right 90. Okay? Those were all of our steps. The little notation. Are you guys okay with that?